Welcome to Pharmacology Teaching Video. Introduction to Pharmacology. Pharmacology is the study of drugs and their actions on body organs. It is derived from Greek word pharmakon, which mean drug, and logos, which means the science. What is drug? Definition of drug. Drug is any substance or product that intended to modify physiological states or pathological system for the benefits of recipients. What is receptor? Receptor. These are target protein macromolecules present on the cell surface or intracellularly that selectively bind and normally respond to endogenous chemicals in the body. Receptor binding theory. For the drug to give its therapeutic effects, all receptors should be occupied to reach minimum response max. Receptor binding characteristics. Receptors are responsible for the selectivity of drug action. Receptors mediate the actions of pharmacologic agonists and antagonists. Drug receptor complex. Responsible for drug pharmacological action. Quantitative aspects of receptors. Dose-response curve. Receptors determine the quantitative relationship between drug dose and pharmacologic effect. What is Emax? Efficacy is the maximum effect max, of a drug. The maximal response, Emax, or efficacy is more important than drug potency. Some characteristics of receptors and signal transduction. Spare receptor. Spare receptors are said to exist if the maximal response, Emax, can be obtained at less than 100% occupation of the receptors. High-efficiency coupling may also result from spare receptors. Spare receptors are not different from non-spare receptors. They are not hidden. When they are occupied, they can be coupled to response. Spare receptors determined by using irreversible antagonists to prevent binding of agonists to a proportion of available receptors, showing that high concentrations of agonists can still produce an undiminished maximal response. Maximal inotropic. So how do we account for spare receptors? In some cases the mechanism is understood. For example, a single agonist receptor complex can interact with many G proteins, thereby multiplying the original signal many-fold. 2. The duration of activation of the effector persists for a longer duration than the duration of drug receptor complex. Example. This is a characteristic for G protein-coupled and enzyme-linked receptors. Signal amplification. A characteristic of G protein-linked and enzyme-linked receptors is their ability to amplify signal intensity and duration. Example, a single agonist receptor complex can interact with many G proteins, multiplying the original signal many-fold. For example, a single agonist receptor complex can interact with many G proteins, thereby multiplying the original signal many-fold. Additionally, activated G proteins persist. Spare receptors. Full response at subsaturating. Desensitization of receptors. What is the mechanism's defense of cells? Tachyphylaxis. Downregulation. Upregulation. Refractory receptors.
Created using Powtoon.